Doing fantastic. So yeah, we get to talk today. This is our first YouTube live series, our first Interrupt Live. How does it feel to be the honored guest?
Well, it's definitely an honor. It's very exciting. I think this is awesome. I'm really looking forward to it.
Yeah, we've been working together for probably something like, what is it, 6
no.
or 7 years? But this is the only time it's just us two. So this will be a good conversation, though. I'm excited about the topic. So yeah, thank you all for joining. Noah and I are just going to honestly chat back and forth about Noah's recent interrupt post when he was making an ESP component out of the Memfault SDK. But before we get into that, I'm going to actually allow Noah to introduce himself. And then I'll introduce myself, and then we'll go on from there.
Awesome. Yeah, thanks, Tyler. So who am I? My name's Noah Pendleton, firmware engineer by trade. Been doing embedded software development for, past 12, 13 years now, I think. I started actually as an electrical engineer way back in, probably shouldn't say 2008 or something like that, I think.
I didn't even know that.
I know, it's wild. Yeah, I did like circuit design, circuit analysis work at a company called APC, which is like a battery backups company here in Massachusetts. And I switched after about like 6 or 9 months of that. I switched to doing firmware development. There was a need there. This was like writing C code, like very old school kind of shop. Did that for several years. So it's like real-timey kind of code with explosive consequences for when you mess up your phase lock loop and that sort of thing. And then I joined the company Fitbit in 2016 and started working on smartwatches, doing like IoT development there. It was awesome, learned a ton. And I had the good fortune of meeting you, Tyler, as well as Chris Coleman and several other folks who had previously worked at the company Pebble. And those guys brought a ton of technology to Fitbit and a ton of interesting things, including some of the pieces that eventually developed into what we do at Memfault, which is the debugging and telemetry stuff for IoT devices.
Yeah, sweet. Thanks, Noah. And yeah, I'm Tyler. I guess I started my firmware career at Pebble, which is now an exciting time given the news that we all heard this week, where Pebble's kind of making a comeback. So yeah, started writing firmware at Pebble, got acquired by Fitbit, met Noah at Fitbit, wrote a lot more firmware, and honestly just got tired of writing so many internal tools and debugging tools for firmware engineers that we had to make a company. So hopefully it's the last time I'll ever have to write a lot of these internal tools, and other companies can just use them, but we'll see what happens. But yeah, let's get on to our topic. So Noah has been writing a lot of the firmware for Memfault. He writes a lot of the firmware SDK, probably more than like 60, 70% now at this point. And one of the things that Noah wanted to do was make this SDK easily installable for firmware engineers that were working with the ESP-IDF framework. And what better way to do that than to essentially build a package for this framework called an ESP component. And so that is what Noah was working on. It was a task that we were basically trying to do to make it easier. And then you wrote an interrupt post about it, because what better way to share with the community what you did than actually write an interrupt post, which is our blog, which a lot of people read. It's one of my favorite places. I continue to learn a lot from interrupt. So yeah, thank you. Let me dig into this topic now. So why did you create an ESP component, Noah, except for that I told you to, and that it was a task that was given to your, essentially Jira board? You came to me with the idea and I was like, let's do it.
Yeah, it's something we've been kicking around for a while. These like ESP component sort of modular software components are something that was developed by Espressif, which is like the company who manufactures the ESP32 series of chips, and they also are the ones who develop and publish the ESP-IDF. It's like ESP Integrated Development Framework, I believe. So that's their SDK, and it's been around for several years now. Originally, it was sort of delivered as this holistic like pile of everything, like batteries included. So it did have the notion of components, but it was all like sort of in one Git repo that you would download. It'd bring you everything, so you'd have a million things, maybe not necessary for a project, didn't matter, you got them anyway. And then everything sort of moved together. So like a new ESP-IDF release would, they'd update all these sort of sub modules within their, it's parent Git repo. A few years ago, they switched to this like modular component model. It's a lot more like how Zephyr manages its subcomponents, where particular library or something like that will be, maintained semi-externally from the main project. This, obviously advantages and disadvantages to that versus like this monolith. But yeah, ESP or the Espressif guys did this a couple of years ago. They broke out all these components. So what happens, like when you build a project that depends on these subcomponents, it'll get pulled down from their registry, when you build and cache locally. And then, yeah, it obviously has like a lot of advantages. You can, update like an example is like the LED bar driver for serial access or serial adjustable LEDs. That was like one of the first components they broke out. And it meant that they could like update that and manage it separately from like these big ESP-IDF releases, which only come every like few months. They could keep things, moving along on this, subcomponent more rapidly. So it's pretty nice.
So they've removed all of this code from the actual Git repo, so it's no longer tracked in it at all. It's just the reference to the URL to the other Git repo that's probably public.
Yep. Yeah, exactly. I think, sort of like a shell game, but yeah, that's exactly what happened.
Got it. Sweet.
And then, yeah, like other middleware companies or projects, I guess, things like LVGL, Wolf SSL, I think. There's several others that were also developing and producing these components. Once this publicly available component registry became available, like Espressif published instructions on how to do it, et cetera, et cetera. And then, yeah, we were like, yeah, we should do this too, because before this was done to add the Memfault SDK to your ESP30 project, it was like, you clone the Memfault SDK repository and hook it up in your like CMake, your build file, basically. So a couple of manual steps. And if you make a publicly published ESP component, then you just add a few lines to manifest and you get the SDK like installed right away, which is really nice. Very nice user experience, I think.
So yeah, so let me paint the picture of the difference again. So usually people would have to have their ESP project. They used to have to download a Git submodule into the repo or a zip file if they want to not track it, but ideally a Git submodule. And then they would manually edit CMake. They would manually edit a little bit of their build system. Did they have to do any like linker script modification, or was that all kind of handled? It was just the CMake modifications they needed to make before.
Yeah, the way we set things up in our SDK, like ESP has facilities for inserting like linker fragments, very similar to how like Zephyr does that. So we were able to. We don't really have too many linker modifications required by our SDK, but there, a few pieces they get sucked in automatically. And the ESP, the like component version of our SDK, like behaves the exact same way. So, yeah.
Got it. Sweet. Is there any requirements for publishing, or is it like how did you actually get it onto the ESP component website then?
Yeah, it's a good question. So the impetus for writing the article or like publishing the article was like that was my journal. I was like, keeping track internally as I was producing this this public SDK. And so yeah, there's a tool called Compode, which is a very cute name for the tool. I love that. That Espressif provides, and that's for like doing component management stuff. So if you ever use like tools, other tools in other systems for like, or in other languages and stuff like that for publishing components, works the same way. You run a command to like package up your component, point at your component directory, and then you can run a command to publish it. I would say the only semi-tricky piece is if you want to publish a component under like a unique name. By default, you log into the component registry with like your GitHub user account. So we would be publishing the component under like the Noah P name, but all you do is send an email. It's actually in the instructions now that Espressif publishes. You just send them an email asking for like a Memfault name was what we went with, of course, to publish our component. But yeah, pretty straightforward. I would say the tooling is perfectly up to the job. It works very well.
Great. And then the GitHub repo, the one that's public, is essentially the source of truth. Like they don't have to actually download the zip, or you don't have to tell them to update. It just pulls GitHub every so often to know what the latest update is.
Oh, in terms of like actually deploying the package to
like if we wanted to, if we had, we have 118 now, we need to deploy 119. Do you actually have to push 119?
Yeah. So it's very similar to like how Rust like creates the IO works, where you have to issue a command to like bundle your package and push it to the registry in the format that they require before like the new version's available. Yeah.
Sweet. The firmware SDK, the Memfault firmware SDK, honestly, I would say is a kind of a behemoth of a project. It's a lot. It's got a lot of examples. It's got a lot of ports. Was there any difficulty with that about making an ESP component, like given its complexity?
Yeah, it is kind of grown quite a lot. We support so many different platforms and stuff, and there's so many different like examples that are included in the SDK. A lot of them are not relevant for ESP32 projects, so we do trim it down a bit. Basically, we have like a Python script that runs when we do a release. There's a few different things that happen on the Memfault side, and one of these operations is to run this Python script that converts our SDK into like an ESP component like form. And one of those things that we do there is to like delete all the extra stuff that doesn't apply. It just reduces the size of the package that needs to be downloaded, which is nice. It goes from maybe a meg or so down to like a few hundred kilobytes, which is nice.
Okay. So it's that Python script that kind of slims it down to exactly what it needs for the ESP component.
Yeah. And I think we were able to make all the modifications in tree. Like I didn't have to do any reorganization of the directory structure or anything like that. I think everything is like, one-to-one. That is described in the article, but that was very helpful for testing. I could just point my ESP32 project directly to the folder where I was developing the Memfault SDK. I didn't have to like do this, rinse and repeat, like, make some changes to the source SDK, regenerate a component, like it's always annoying when you have to do stuff like that. So
any surprises along the way that made it more difficult or maybe even easier?
The expressive documentation is pretty good on this topic now. I think when I initially looked at it, when they just like opened up the registry for public publishing, it was kind of like, you had to go and look at the source code of the tools to see what your manifest needed to look like, stuff like that. But things got into shape really quick there. So I was quite impressed by that. It made things very easy. And the best part of all was that there was like, I think the LVGL was the one I was using as a reference, but it was very nice to have publicly available components that are already doing very similar things to what we needed to do. I could just sort of like follow in their footsteps for a lot of the pieces.
Yeah. What was the component you used as the reference for you that you stole all their structure from?
Stole, it's an homage. It was LVGL was the one. So the lightweight vector library.
Yep.
Display, which is cool.
Awesome.
Yeah, that library is great. It's a ESP component, like just in its main directory structure. It's it's a Zephyr component. I think it's like it fits into other operating systems that Minute. Yeah, I think you can download it and install it into like Minute projects. It's pretty cool.
Still,
they just kind of added everything,
Honestly, that was Memfault's first, I think, package that could be built was Minute as well. So
yeah.
Do you have any more manual steps to actually publish it now, or have you kind of built it all into CI when we publish that tag in the Memfault SDK? Like how, I know you're a fan of automation. It's kind of to an extreme degree. Were you able to automate everything around the ESP component?
Well, Tyler, yes.
let me explain.
Yeah, the nice thing about a lot of these tools is that they're all command line first, which means you don't have to do much to automate like the steps you were running already when you're testing in like development process. You just run the same things in CI, and it makes things very simple. I also do heavily appreciate when package managers like this have like a dry run mode. So you can like do a test without like actually pushing data. Oh man, it's like worth a ton because maybe you like mess up your manifest or something. Very helpful. Excuse me. So everything is hooked up in automation. So when we push a tag to our public like GitHub repo, like when we do a new firmware SDK release, triggers the job. Generates this package and it pushes it to ESP component. We also have like a periodic check to make sure like the component, I think we run it nightly now, to make sure the publicly published component works in a variety of different circumstances because people use our SDK in different sort of project setups like library, blah, blah, blah. Yes, it's all about automation, name of the game. If you have computers watching your back.
If Noah has to do the same thing 2 or 3 times, there's usually a PR for some sort of CI change in about 2 hours. It's like I'm done with it.
Got to make it easy.
So yeah, you've been using the ESP-IDF framework for quite a while. Honestly, a lot of our customers use it. What's your take on it? What's your thought? How do you like it?
It's a fairly complicated stack for sure, but I think like any IoT project of that magnitude is like complicated. It supports a lot of protocols and different like application types. it's good, I think. Yeah, the Espressif team does a great job. A lot of it's, open source. Obviously, like the Wi-Fi pieces are proprietary, so you do get some proprietary code in your project.
But it's just the Wi-Fi driver, basically.
Yeah, and everything else in the application stack is using a lot of like popular open source libraries. The code in the repo itself is generally like pretty high quality. Documentation is good. Yeah, it's been honestly a joy to use. I'm especially happy that they went with like CMake as the build system. Makes things really easy to use and modify if you need to. And the other piece I would say is really great is bootstrapping the SDK, like getting a toolchain installed. It's really good. It's like, close to how Zephyr is doing it these days, where you have like a little bit of scripting to like get your system set up and able to build a project. You can get going like so fast with it now. Very, very pleasant to use. Yeah.
Yeah. Love I guess it's sometimes extreme, but the ones that download all of the tools you need, put it into a little virtual environment, and then you can scrap it whenever you need. Also, it makes like reproducible builds so much easier. So
yeah, it's fantastic. They also maintain a Docker image, which we use in our CI too. So we can use like a official, it makes things very easy. Yeah.
Very cool. So yeah, and then you turn it into an interrupt post. Honestly, thank you. Thank you for sharing it with the world. What's going to be the next interrupt post? Do you have any ideas?
Oh man, I have such a long list of like things I want to look into. One that's been on I actually have two I think would be very interesting. One is comparing like standard atomic, like the C atomic primitives, with stuff that's provided by like the Rust library and stuff like that. For like synchronization without an RTOS. I think there's a lot of interesting things to poke at there, like performance and stuff. The other one is I wanted to compare like some popular SSL libraries across a couple of different platforms.
Yes.
That's like a big project, but man, is it interesting? So yeah, maybe that'll be the next one. I don't know.
I would love that. Out of memory bugs on different SSL projects and different cert sizes and cert complexities. Anyways, there's a lot there too. Yeah. You could go write the post, Noah. I'm ready to read it.
Another one that we went through recently, which is probably worth an interrupt post, is debugging and tuning network buffer sizes on Zephyr. Zephyr RTOS, super complicated, or I shouldn't say super, but relatively complicated network stack, and a lot of knobs to turn. It can really make or break your project. So yeah, maybe that's nice.
Got it. We only have a couple more minutes. Do you have any final words of wisdom for those out there who are trying to either, I guess, download or use, or even build their own ESP components?
Oh gosh.
I know. I told you I put you on the spot.
The documentation is great. Looking at examples, that was what really did it for me. And then make sure you're testing things. Make sure you test it thoroughly before you publish.
And use the dry run. That's okay though. But also, if you mess up when you publish it, just publish it again.
Publish a new one. Yeah.
Not the worst one. No one's gonna go back and download an old version of the component. Maybe.
I will say, big shout out to Espressif. They're very, very responsive over like GitHub issues, or if you want to hit them up in their Discord or in the interrupt Slack. In fact, there's a few Espressif engineers, and that was helpful for me too. I did have like a few questions that weren't documented at the time, and they were great. Love working with them. So yeah. Sweet.
And then, do you do most of your writing? Where do people follow your future work? Where do they read this SSL post? Is it Interrupt?
I put all my long form stuff on Interrupt. Great blog, man. We have some really nice articles lined up too. I'm not going to do any spoilers because Jilly would kill me, but some really awesome stuff in the pipeline too. Yeah, it's been great. I think it's grown very nicely over the years, Tyler.
I think a lot has happened since Chris wrote his how to debug a hard fault, and I wrote a bunch about unit tests. However, I'm so excited that all of the unit tests that I've written in my entire career have been published in the last like 3 or 4 days, though. I was looking back at all the unit tests I wrote at Pebble, and I was like, wow, these things are beasts. Anyways, very, very good stuff. Great. Well, we were hoping for a Q&A, but it doesn't seem like YouTube Live is working with us all that well. But we are basically going to wrap it up now. We may get Q&A working, but thank you, Noah. Thanks for the chat. Really, really fun to chat about the ESP component. I hope the listeners were able to learn a little bit. You'll keep updating the ESP component, I'm sure, and we'll go from there. Thank you all. Thank you, Noah.
Thanks, Tyler.
I think we're good. It's off.